All right, so here I'm asked to find the x values where the tangent line is horizontal. So the tangent line is the derivative. So where the derivative has a slope of 0. Horizontal means slope of 0. So I want to find the x values where the slope is 0. So looking at this, the product rule is going to come into play. So to take the derivative, I'm going to have first d second plus second d first. All right, so now I'm going to find the x values where the derivative is equal to 0. Plus 6x e to the x. Okay, so again, when you have things equal to 0 like this, you want to factor out. You don't want to divide, but I want to see what there's something I can factor out on this side. So I think I can factor out a 3, an x, and an e to the x out of these terms, right? So this, what do I have to multiply to get to here? I think it's just x, right? And then this times what will give me this? That'll give me a positive 2. So I get all of these three things equaling 0. So I get x equals 0, right? This x equals 0. E to the x equals 0. And x is equal to negative 2. I know that e to the x is never 0, so this just gives me no solution. So there's two answers, x equals 0 and x equal negative 2 when the derivative is equal to 0, or when the tangent line is horizontal. All right, so fourth derivative. All right, so let's start by writing just the function down here. It's 3x times e to the x, and I'm just going to emphasize product rule with the dot so I don't forget it. So one derivative will be first d second plus second d first. That's one derivative. Second derivative, we did take the derivative of this, right? So I got product rule again. So first d second plus second d first. So this is the derivative of this term, right? Now, carrying along here, this is just a constant, so I'm carrying that along. The derivative of e to the x is e to the x. All right, anything joining together here? I think I can join these two together, right? Okay, so let's just do it. Make my life easier in the next step. Okay, so now let's go find the third derivative. So 3 dashes for the third derivative. So to take the derivative here, product rule again. First d second plus second d first. So the derivative of this gives me these two terms. And then to take the derivative of here, I carry along the 6 and I get e to the x. So again, these two can join together. So let's put them. So I'll get 9 e to the x. Okay, after 3 little dashes up here, I don't write any more dashes. I put the number 4 in parentheses there. Okay, so this is just what you need to do. Just get used to the fact this means fourth derivative. So product rule one more time. First d second plus second d first. Again, product rule here to get these two terms. And then the derivative of this gives me 9 e to the x. All right, so putting them together. Oops. Yeah, no, that's right. E to the x. And then plus 12 e to the x's. There you go. All right, so let's look at what we've got here. More derivative application. So find all the values of x on this function where the tangent lines are perpendicular to this line. Perpendicular slope. So I know the slope that we're talking about is negative 1/2, right? So I want the tangent line, so I want the derivative equal to negative 1/2. Okay, so let's go find the derivative. Finding the derivative, you see the quotient rule. So y prime will be low d high, which is 1, minus high d low, which is another 1, square the bottom, and off you go. So we're going to have that. We have reason to simplify the numerator. So I have x minus 2 minus x all over x minus 2 squared. So the derivative simplifies to negative 2 over x minus 2 squared. Okay, that's my derivative. So I'm trying to find the x's that make the derivative equal to negative 1/2. So I'm going to set my derivative equal to negative 1/2. So let's cancel the negatives and let's cross multiply, right? So I'll get 4 is equal to x minus 2 squared. Then I'm going to take the square root of both sides, so I get a plus or a minus 2. So I get negative 2 is x minus 2, or 2 is x minus 2. So solving this one, I get 0 is x. Solving this one, I get 4 is x. So I get two different x values where the tangent line is perpendicular to that line. All right. Okay, so let's look at this one here. So here I have an h and a k. So h has product rule, k has quotient rule. So let's first find h prime of x. Then I'll take the step to plug the 3 in to find this. So h prime of x, I see product rule. So first d second plus second d first. So now I'm going to find h prime of 3. So this means use x equal 3. So I have f of 3, g prime of 3, g of 3, f prime of 3, and they did give me enough information here to solve this. So f of 3 they tell me is 2, g prime of 3 they tell me is 5, plus g of 3 they tell me is negative 1, and f prime of 3 is 4. So I get 10 minus 4, or 6. So h prime of 3 is 6. So now let's go find k prime. So let's first, move it up here. So let's first find k prime of x. So k prime of x, I'll be using quotient rule. So low d high minus high d low, square the bottom, and off you go. All right, so now let's go plug in x equals 3 everywhere. So g of 3, f prime of 3. So at this point it's just kind of a big puzzle, right? Let's get rid of that extra line. G prime of 3, I meant to put a 3 in there. 3 all over g of 3 squared. Okay. G of 3 is negative 1, prime of 3 is 4, f of 3 is 2, g prime of 3 is 5. G of 3 in the denominator is negative 1, but I'm squaring it. So I get a negative 4 minus a 10, so that gives me a negative 14.